Welcome to the city of Stockholm and to the conference Digitalize in Stockholm 2023. I am a senior scientist at RISE. My name is Mikael Popov, and together with my colleague Alex Jonsson from RISE, but also Barry Brown and Moira McGregor from Stockholm University, as well as Sebastian Wallman, Marco Moletto, Matteo Tadinello, and Sara Norskova from FLOX Robotics. This presentation is about autonomous drones and AI-assisted computer vision for near real-time mapping and management of wild stock. Welcome. We start with a drone equipped with a computer powerful enough to make real-time inference on the video from the drone, and it looks something like that. And the algorithm is also completed with a tracker, which allows us to put an ID on each animal. And in this case, we can keep track on the individual animals and also count them. So the idea is to have an algorithm trained for each specific animal, so we can distinguish between different ones. And we can perform individual tracking in case there are people which accidentally managed to appear in the picture, so they can be removed for, say, privacy concerns. And the tracker will help us to keep tracks on separate and individual animals and perform in such a way an estimate of the amount of animals we have observed. The drone is also equipped with a special unit which produces ultrasound, and it has been tested by partner FLOX and to successfully scare off the animals and in this way herd them. This is an example how the ultrasound repellent works. So, here's at night. As soon as the ultrasound signal is activated, the animals, in this case boars, move away from it. It is the same illustrated on deers during the daytime. So as soon as the signal, it's the same. So the signal is activated, the drones are scared away. And this is exactly the goal of the technology, so that we can get the animals away from certain areas. So the drone performs the task of identifying the animals and eventually counting them. So this information can be sent further from the drone to a central location, to a server with the IDs of the animals. And this information can be assembled and put on a map with the location and with the timestamp, and if required, with certain, say, with the pictures of animals. So, and this can be done from a single drone, or this can be done from many drones. So in this case, we will have a good, let's say, almost real-time overview of the detected animals, but also the historical perspective. So in this way, this is the idea behind the unmanned aerial system. Basically drones as a service, which can be used for monitoring and repelling wild stock. So the idea can be developed further. So if the drones can be they can be flown autonomously, so they can be by schedule or by some algorithm, can fly by themselves, recharge, and fly again. So in this case, we can think about, say, a whole fleet of drones, which can be placed in different locations. And the idea is that you may have the drone management platform, where basically you control and a good overview picture and control over a fleet of drones, which can cover large areas, well, proportional to the number of drones you have. There are currently ongoing tests with real-life cases performed by project partner FLOX. One of these cases is in the city of Stockholm. It's about scaring off geese from beaches of Stockholm away to the nature, and this looks like that. Let's start the video. So this is real time. So this is a sort of real life opportunity to verify the technologies, both when it comes to identification of the, in this case, geese, and also test the repellent technology, how efficiently it works in the field. Another tested case includes the city of Malmö airport, and it's also about detecting and herding off, in the first place, birds, but also other animals. And there is also a video. So the expected outcome of this project is that we eventually will have a system, a drone-based system, which is able to map and first identify and then to map different kinds of animals over larger areas. So, and it's necessary to use the ultrasound technology to repel the animals from the crops in particular. And this is done in the real time. It can cover very large surfaces using a fleet of drones. And it records the location, the ID of the animal, and also the timestamp. So, and this all eventually is visualized on a map somewhere in a central server. So it gives a good overview and of the current situation, but also in the historical situation. It's also visualized, which can be tailored for different applications, for different parties. And the system is compliant to regulations in EU and also overseas in the US. And there is also an idea about how this will work financially. So, currently it's a subscription-based model where you can buy this as a service, so both of mapping the animals but also scaring them off. And it's expected that the one drone will cover a relatively large surface of 200 hectares. Thank you for listening, and in case you have any questions, there have been contacts on the previous slide. Thank you very much again, and have a nice day.